So it is preparing. Got it. Okay, so it looks. Okay, so I'm going to ask you to just stop your share for a moment. No, I'm going to do that. Okay. So, good evening and welcome to our audience. I don't know. Well, they would only have had a chance to start joining the stream now, so we'll give him a few moments. Just keep a watch on how many people are shared. At the moment, it's probably me and Rory. Are you watching the stream as well?
No, I'm doing this live with you.
Okay. No, so then there is one other. And let me just see if I can just get a nudge. Okay. Got a Malcolm here. Hi, Malcolm. It usually takes a few minutes for everybody to join us. And as I said, I wish I could send them all pizza to make them enjoy the old experience we were all used to. I just want to get this info up on the screen. So usually at the end of a meetup, we send out a feedback form and we ask people to write at the end to tell us if they're interested in being in the draw for a JetBrains license. And from the last one, we only have one, which is Tebogo Asagai. So Tebogo, congratulations. I'm going to send you a document with a key that is probably worth about $250, depending on which of the IDEs you sign up for. Whether, well, if it's not IntelliJ, then it's going to be worth less because they're all cheaper. IntelliJ is the one that costs the most and it can probably do everything. But enjoy that, Tebogo. I hope you get some great benefit from it. And let's see if we've got anybody else. Oh, we've got 10 people now. So that's actually a fairly nice number. We've been struggling to hit even 10. And when we've had in-person meetups, apart from one, we usually had at least between 30 and up to 90 or even 100 people at in-person meetups. But I'm not 100% confident that it's safe yet. We see people coming back from conferences and they've contracted COVID when everybody made all the necessary preparations and taking care. And I'm not sure if it's worth the risk. We'll put out a poll to gauge the audience, but I'm not going to eat into Shai's time anymore. So I'd just like to welcome Shai Almog. He is a developer advocate at Lightrun, and he's going to talk to us about debugging applications in Kubernetes, which is something I've been doing the last few weeks. So I'd love to see what I can learn from him. And I'm going to hand it over to Shai. So Shai, thank you very much for joining us and giving up your time.
Thank you.
And if you please.
Okay, thank you for that great introduction. And it's great to be here. I'll share my screen and start with that. So I'm assuming you can see this. And let me know if not. So, hi everyone. As we said, I'm Shayar Mog, and today we'll talk about debugging at scale in production. If you have any questions, please make sure to, I need to move this Zoom stuff, it's in the middle. Please make sure to ask in the Slack channel dedicated to that. I'll look through it during the talk, and I'll discuss questions as they come up. If it's applicable, you'll see me look to the side to see if it's on the Slack there. So just to say a few brief additional words about me, I was a consultant for over a decade. I worked at Sun, founded a couple of companies, wrote a couple of books. I wrote a lot of open source code, and I currently work, as we said, as a developer advocate for Lightroom. My email and Twitter accounts are listed right here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. By the way, Rory, pay attention to that. We discussed this short attention span of people recently. So I have this series called 140-second ducklings, which is where I explain complex things in 140 seconds, literally the length that Twitter allows you for a video. So it's really short, bite-sized videos that talk about debugging and the complexities of all these things, from very simple all the way to some lots of stuff most people don't know about. So it's I'm really excited about that, and I just finished the first batch of 17 videos, so it adds up. And check it out and let me know what you think in Debug Agent at Twitter. So I was talking at a conference recently, and they did this amazing slide. They did this sort of mind map of this presentation. And I just love it. I took it and I added it as part of the slides, and I think it's great. I'll show it again in the end, where it will sort of all hopefully click together, so I won't stay here for too long. Containers and orchestration revolutionized development and production, no doubt. But in a way, Kubernetes made debugging production issues harder than it previously was. In the past, we had physical servers we could just work with, or even VPSs. Now we face a much greater difficulty in this age due to three big challenges. The massive scale enabled by Kubernetes is a huge boon, but it also makes debugging remarkably difficult. We need new tools to deal with this scale. We have multiple layers of abstraction to the deployment, where failures can happen in the orchestration, container, or code layers. Each failure requires a different set of skills and solutions. Tracking the cause to the right layer isn't necessarily trivial. Finally, there's the bare-bone or lean deployment problem when debugging. This is the first problem I want to focus on. We'll get to the other two soon enough. It's the problem of the bare-naked container. We can connect to a bare-bone container, but we have nothing to do inside it. Nothing is installed. We can inspect logs, but that relies on luck. Furthermore, if your logs are already ingested by a solution like Elastic, you probably don't have anything valuable to do within the bare-bone container. kubectl debug solves these problems and can work even with a crashed container or a bare-bone image. The kubectl debug command adds an ephemeral container to a running pod. An ephemeral container is a temporary element that would vanish once the pod is destroyed. With it, we can inspect everything that we need in the pod. Most changes we do in it don't matter. They won't impact the pod after we're gone. It works with bare-bone container, The way it does this is with a separate image. So we can have an image that includes everything in it. The container spun from the image is ephemeral and can include a proper distribution and the set of tools that we need. kubectl debug was introduced in version 1.23. So if you're still in an older version, you will need to wait for that. If you use Kubernetes, you need to check the version they use. So let's start with a simple demo. As you can see, we have here a few pods. We're experiencing an issue and would like to increase the logging level so we can better see what's going on. I can use exec and log in directly to the live pod. I log in with a proper bash shell. I'm sure most of you did that in the past, as it's pretty easy. Here I can just use standard commands like cat and grep to check logging levels. This is all good. We can see the current level is at info. Unfortunately, I don't even have Vim if I want to edit this file. Now, when the container has apt or APK and when the pod isn't crashed, I could, in theory, just apt get install Vim. But that's got its own problems and is a painful process. We don't want people in production just installing packages left and right. The whole idea is a stateless deployment in Kubernetes, the fact that we don't change these things. Even if it's cleaned up, the risks are sometimes too high. Pods shouldn't be touched in production once deployed. All the information and state of a pod should be described in its manifest, unless it's a strictly stateful pod like a database, etc. So installing like this is problematic. So let's exit for a moment and try connecting again with kubectl debug. I'll use the busybox image in this case, and we'll see how that works. Notice this is the image referenced in the kubectl debug documentation. So I'm connected to the pod again, or so it seems. Technically, I'm connected to a new ephemeral container and not to the pod directly. This is an important distinction. But as you can see again, I don't have Vim, or really any of the tools I would expect, like Visual VM, Traceroute, etc. I can fix that. I can create an image that represents everything I need and package all the tools I need, then pass that image to kubectl debug and just use these tools. But here's the thing, I'm not unique. We're all pretty much the same. We all expect the same things in our debugging session. And that image I can use is probably the same image that you can use. So why not have one generic image for all of us? This is where Coolkits comes in. Coolkits was created by Tom Granot of Lytra. Coolkits is an open source project that includes a set of opinionated, curated, platform-specific tools for kubectl debug. So you can have everything you might need at your fingertips while debugging. So what does that mean? When you use kubectl debug to spin up an ephemeral container, it's built using a Coolkits image. Currently, there are 4 standard images. A Go image that includes tools such as Delve, pprof, GoCalvis, and many others. A JVM toolkit, which includes tools like SDKman, JMXterm, Honest Profiler, Visual VM, and again, much more. The Node version includes NVM, NVM, 0x, VTOP, and much more. And finally, the Python version includes PyEnv, IPDB, IPython, and again, expectedly, much more. But this is just the tip of the iceberg, as all the versions include the many tools you would expect in any proper debugging session, such as Vim, HTOP. We also have lots of networking tools like Traceroute, Nmap, database clients for Postgres, MySQL, Redis, and again, so much more. So let's continue from where we left off in the demo. we can disconnect from the current session and then spin up a new session with the coolkits image. Notice we can use the shorthand KK command for many operations, which I don't use here, but you can see the syntax in the coolkits docs. Specifically in this case, notice I used the JVM version of coolkits, which I chose because, well, I'm a Java guy, you're Java people, hopefully, so it clicks. But if you're using a different environment, you can use what fits there. In coolkits, pretty much every tool I want is already pre-installed as part of the image by default. This means we can just connect and everything is already there. Since we're all very familiar, very similar in our needs, coolkits includes the common things most of us need. Based on the platform or language, it has sensible defaults and comes with Ubuntu as the distro. This is important. You have a full distribution like you would have in a desktop or in a regular server. This is very helpful for debugging, obviously. So you get everything you need, even when debugging a barebone container. Notice that thanks to kubectl debug, we have full access to the main application containers file system and the pod's process namespace. So we can do everything there while residing in a more convenient environment. It's having our cake and eating it. So to finish the story from before, I can just use vim to edit the file and change the logging level to error, which I can then confirm using cat and grep. I can also do a lot of other things, such as profile using a profiler, debug with GDB or JDB. I can use JMXterm to perform JMX operations, which lets you configure the way the JVM behaves in runtime, and pretty much anything I can do in a local machine. To give you a sense of what coolkits installs, this is the list of packages for the JVM client. And this is bound to grow as you can all submit pull requests with your favorite packages. This is just the JVM specific image. The other images contain similar tools at a similar scale, and you can get all of that thanks to kubectl debug and coolkits. What if what you're tracking seems to be an application bug? This is a common occurrence for sure. We might not know it at this stage, but that might be the place we want to start investigating. We can try using logs and probably should start there. But more often than not, the issue we need solved isn't logged. We can try using various observability tools. They're great, but not for application level issues. They rule for big picture analysis and container level problems, not for application level problems. We can use one of the debuggers in coolkits to track it. That would only work if we know the server where the issue manifests, which we sometimes do know. It's remarkably risky though. Connecting to a debugger to a production environment can lead to multiple problems. Stopping on a breakpoint by accident, using a conditional statement that grinds the system to a halt, exposing a security vulnerability. JDWP is the Java debugging wire protocol. There are several such remote debugging protocols we can use. It suffers similar issues. So let's dive into all of these options, starting with just using a regular debugger. So here's the first problem we run into with a debugger. We can't just start using it. We need to relaunch the app with debugging enabled. That means killing the existing process and running it over again. That might not be something you can just do. Furthermore, running in this mode is a big security risk. Notice I limit access only to the local server, but still it's a big risk. Leaving a remote debugging port enabled in a deployed server code is considered a huge security vulnerability. If hackers can ride a different vulnerability, they might be in a position to leverage this from a local system. Still, if we do this for a short period of time, this might not be a big deal, right? In a different window, I need to find the process ID for the application I just ran so I can connect to it. I can now type it into the JDB command, and now I'm connected with a debugger. I can add a breakpoint using the stop command. Naturally, I need to know the name of the class and the line number, but I can set a breakpoint to stop at it. And once I stopped, I can step over like I can with a regular debugger. However, this is a pretty problematic notion on multiple fronts. First off, I'm literally stopping the thread accessing this application. That's probably not okay on any container you have in the cloud. There are ways around that, but they aren't trivial. The second problem is different. So I'm old, and people automatically assume I love the command line. And I do to some degree, but I love GUI more. And when I started programming, there was no option. We didn't have IDEs on the Sinclair or an Apple II or on a PDP. But now that we have all of those things, well, I don't want to go back. I programmed in Java since the first beta went on the internet. And this was the first time I actually used JDB. I use command line tools when they give me power, but debugging via command line, I can't. It's terrible. The obvious answer is JDWP. We have a remote debug protocol that's supposed to solve this exact problem, right? But this is a bit problematic. If we open a server, the server to remote access with JDWP, we might as well hand the keys to the office to hackers. A better approach is tunneling. During the age of VPS, we could just use SSH tunneling. Like this. We'd connect to a remote host and forward the port where the debugger was running locally. Notice that in this sample, I used port 9000 to mislead hackers scanning for port 5005, although it wouldn't matter because it's SSH. We can do the exact same thing with Kubernetes using port forward command to redirect a remote JDWP connection to the local host. Port forwarding opens a secure tunnel between your machine and a remote machine on a given port. So when I connect to localhost on the forwarded port, it seamlessly and securely connects to the remote machine. Once we do that, I can just open IntelliJ IDEA, add the run configuration for remote debugging, which already exists and is pre-configured with the defaults such as port 5005. I just give the new run configuration a name, and we're ready to go with debugging the app. Notice I'm debugging on localhost, even though my pod is remote. That's because I'm forwarding everything from the remote container. I make sure the right run configuration is selected, which it is. We can now just press debug to instantly connect to the running process. Once that is done, this feels and acts like any debugger instance launched from within the IDE. I can set a breakpoint and step over and get this wonderful debug GUI I'm pretty much used to. This is perfect, right? Right? Well, not exactly. It's got quite a few drawbacks. As we can see, there are so many problems in this process. First and foremost is the need to restart the process. We can possibly run with debugging turned on by default, but that's a huge risk. Then it's breakpoints. They break. I heard a story years ago about a guy who debugged a rail system, and it literally fell into the ocean while it was stopped on a breakpoint because it didn't get the stop command. It was on a cliff, and just the user placed a breakpoint on the code that after the command was sent to start and before the stop command was sent. And so it just kept going and fell. I don't know if it's an urban legend, but it's plausible. It might have happened, and It might have happened because, stuff like that happens to us with debuggers all the time. All remote debugging protocols are inherently insecure. But I can personally attest about JDWP, which I'm familiar with. It's very insecure. In fact, there were CVEs already about products that just left it open, that just turning on JDWP, that's a CVE automatically. It isn't designed with security in mind. It's designed for debugging. It exposes your production. It's a huge danger. But it's also a stability risk. How many times did the debug process crash on you? Imagine adding a breakpoint condition that's too expensive or incorrect. It might destroy your app in production. Just loading the variables in the watch can cause unforeseen problems in some cases. The protocol itself is flawed in those aspects. For instance, it requires several stages to perform things directly on the server. So if you have a networking issue in the middle, your server might go down. It's problematic. But this is the worst thing about JDWP. You might be breaking the law. Say your app has a place where it takes user credentials for login. Maybe a third-party library you use does that. You can still place a breakpoint there and steal user login details. Worse, you can elevate the permission of your own user account because everything is writable inside the debugger. Just set a value of a variable and you're administrating. This goes against privacy laws and is very damn likely. 60% of security breaches in an organization happen because of an employee. There's often a misconception that about security that targets the outside world only. That just isn't true. The risk is from one of the other engineers being disgruntled and using the debug port that we left open to essentially steal company data, user data, money, anything. It's complete access, unfettered in any way whatsoever. It's a huge, huge, huge risk. I didn't forget about this slide. This is an even more important aspect. Everything we discussed up until now assumes we know the exact container where the problem is happening. In real life, this is rarely the case. We can have thousands of containers in a real-world deployment. How do you debug something like that? The debugger can solve the depth issue well. It lets us dive into the code despite all its problems. But it wasn't built for the scale of production. That's where developer observability comes in. We used to call this continuous observability, but developer observability makes more sense. It's a newer set of tools designed to solve this exact problem. Observability is defined as the ability to understand how your system works on the inside without chipping in your code. The without chipping in your code portion is key. But what's developer observability? With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? In practice, we add an agent to every pod. This lets us debug the source code directly from the IDE, almost like debugging on a local project. So to start, I'll demo these things with Lightrun, which you can store for free in lightrun.com/free. But the concepts and the principles I'm explaining here are applicable to every developer observability product out there. Obviously, I'm obliged to say that Lightrun is by far the best. So that's contractual obligation. You can check out the Lightrun docs for more details on installing it in Docker, Minikube, etc. Unlike kubectl debug, we need to install the agent before the problem occurs. So we need to be ready for a case where we need to debug production. So when we run into a problem, we'll be ready for that. Unlike JDWP, develop observability tools, all of them work in this way, are far more secure because you don't connect directly to the server. You connect to a management server, and it hides the instances of the pods, of the containers. So this is the prime main app in Kotlin. It simply loops over numbers and checks if they are prime numbers. It sleeps for 10 milliseconds, so it won't completely demolish the CPU. But other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints the results at the end. We use this code a lot when debugging since it's CPU intensive and very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting log opens the UI to enter a new log. I can write more than just text. In the curly braces, I can include any expression I want, such as the value of the variable that I included in this expression. I can also invoke methods and do all sorts of things. But here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. And that's because tools like Lightrun and some of the developer observability tools, not all of them, run in a sandbox. And so everything that you run is read-only and can't make any changes to the running application. Furthermore, it can't abuse CPU. So if you use too much CPU, your code will get throttled. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, which is also supported, you will see a marker on the side. Once a log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there's a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This is just what I was talking about. The sandbox detected that the log evaluates its expression too much and might impact the performance of the production application. And so it throttled it. It made sure that we won't use too much CPU and won't harm the production application by taking up too much of its computing power. And so it throttled it for a few seconds just so it won't damage our production. And that's very important. Let's move on to a different demo. This is a Node.js project that implements the initial backend of a microservice architecture. This is the method that gets invoked when we click a movie and want to see the details in this particular demo. This time I'll add a snapshot. Some other developer observability tools call this a capture or a non-breaking breakpoint, which to me sounds a bit weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now I'll just access the portion in the front end that triggers this code. And we now wait a second and the snapshot is hit. So what is the snapshot? It gives us a stack trace and variables just like a regular breakpoint we all know and love. But it doesn't stop at that point. So your server won't be stuck waiting for a step over. Now, obviously you can't step over the code. So you need to step by individual snapshots. But this has huge, huge benefits, especially in production scenarios. But it gets better. This was a relatively simple demo in terms of observability. let's up the ante a bit and talk about user-specific problems. So here I have a problem with a request. One specific user is complaining that the list on his machine doesn't match the list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reloading all the time. So the solution is to use a conditional snapshot. Just like you can with a regular debugger, you can use a conditional breakpoint, same thing. Notice you can do a conditional log, a conditional metric, and everything like that. It all works exactly the same. This is one of the key features of all developer observability tools. I add a new snapshot, and in it, I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user. That's experiencing a problem. Notice I use the fully qualified name of the class. I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's a good practice to be more specific. So in Java, import isn't an actual thing. It's just part of the Java language. The class file always has full class names. So the agent runs in the pod in the production. And over there, it doesn't see your source code, which is a really important part of Lightroom specifically. Other developer observability tools are exposed to your code in some cases, not all. And in those cases, they don't necessarily require the same level of detail, for better and for worse. You know, if you're okay with the tool vendor having access to your code versus if, well, we don't. So after you press OK, we can see a special version of the snapshot icon with a question mark on it, like a breakpoint, a conditional breakpoint has that question mark. And this indicates that this action has a condition on it. Now it's just a waiting game for the user to hit a snapshot. This is the point where you normally can go make yourself a cup of tea and even go home, check the next day. That's the beauty of this sort of instrumentation. In this case, I won't make you wait long. The snapshot gets hit by the right user, despite other users coming in. This specific request is from the right user ID. We can now review the stack information and fix user-specific bugs. The next thing I want to talk about is metrics. APMs give us large-scale performance information, but they don't tell us fine-grained details. Here we can count the number of times a line of code was reached using a counter. We can even use a condition to qualify that. We can do something like count the number of times a specific user reached that line of code from South Africa, which is valuable for some cases. You know, are people in this area using this specific functionality? We also have a method duration, which tells us how long a method took to execute. We can even measure the time it takes to perform a code block using a tick-tock. That lets us narrow down the performance impact of a larger method to a specific problematic segment. In this case, I'll use the method duration. Measurements typically have a name under which we can pipe them or log them. So I'll just give this method a duration clear name, method duration a clear name. In this case, I'm just printing it out to the console, but all of these measurements can be piped to statsd and Prometheus. I'm pretty awful at DevOps, so I really don't want to demo that in this case, but it does work if you know how to use these tools. As you can see, the duration information is now piped into the logs and provides us some information on the current performance of the method. The last thing I want to talk about brings all of this together, and that's tags. We can define tags to group agents together, such as production, green, blue, Ubuntu, etc. Every pod can be part of multiple tags. every action we discussed today can be applied to a tag, and as such can run on multiple machines simultaneously and asynchronously. This solves the scale problem when debugging. So when we put a snapshot on a specific user reaching a specific line of code, we can place that on a tag. And even if we have a huge cluster, we'll still get the right response when a user hits that method, even if he hits it on pod A, on container A, or container B, or container C. It will still work the same way all around. So let's go back to the list of drawbacks we had with debuggers and review it again. So you can keep an observability agent running all the time, since it's designed for this case, unlike JDWP, which you can't really run a server with JWP securely. We don't have breakpoints, snapshots don't stop. They're secure by design and are read-only. And this is true to varying degree for various implementations. Check your vendor for those cases. You can't destroy the server, and your CPU is throttled, so you can't do any damage in most cases. Again, check the vendor, each vendor differs here. And I don't know, I can speak about everyone. I know that some companies do offer PII reduction and block lists, both of which provide you with tools to block developers from placing actions within specific files. So for instance, you can't add an action to any file related to logging in, and you can block that and select it explicitly. PII reduction, private personal information, personally identifiable information, important for me to remember that initial, is a tool, is information like credit card numbers and things like that, which might put you in liability for laws or regulations like GDPR, etc. And if you write it into logs by mistake or on purpose, it's a huge problem, both for those laws and for credit card processing companies. And so PII reduction lets you block patterns that look like credit cards, like all sorts of problematic information like that, bank account numbers, etc., social security numbers. So it lets you block all of that information. And so in closing, I'd like to review some of the things we discussed today, and hopefully this mind map makes more sense at this point. kubectl debug made debugging crashed pods possible. It also made it possible to debug a pod based on bare-bone images. Coolkits made kubectl debug easier to use with pre-installed tools, and debugging an application in an existing container in production is a difficult and risky process. Finally, developer observability tools enable deep, secure, and read-only debugging at scale, and you should check them out. And hopefully, you will learn how to use these tools and this vertical, because the big challenge here is educating the marketer on the existing of these tools. Thank you.
Applause.
Thank you. Yeah.
This was pretty awesome. To be honest, I didn't even know all of this was possible.
It's like a jump box.
In hindsight, it's obvious, but
it's like a jump box on steroids. All the cloud providers have these jump box, but they like say, here's a jump box. They go, what are you supposed to do with it? Don't know yet. You'll find out a way to use it.
Yeah,
I've been fighting with stuff, so I definitely can see a lot of value in this. I just add this one idea. in the event where you actually do want to use the debugger, do you know if anybody's put together a solution where if you activate the debugger, you would get interaction with your whatever you've configured on your ingress side, so that you can have new traffic diverted to another pod, so that you can step through the
in production or locally when you're debugging a
locally. I don't think I would ever do that in production, because I mean with this tool set you can collect
locally,
the data
why do you
need.
So when you're running locally,
you won't need it. Yeah, that's true.
Yeah, locally you have more control, and locally it makes a lot of sense to debug with the regular JDWP debugger, and that's indeed a great use case for that. There's a bit of a debate in the industry whether staging should be debugged using developer observability tools, which a lot of our customers do. They use it for staging as well, because first of all, they want to get used to that environment. And also they don't, even at the staging level, they don't want to mess with opening that to the developers to start connecting, because they know they'll abuse it. And they want it to be, okay, staging and production are DevOps, and there's this sort of segregation. That's, and I'm using a bad word, segregation in this case, but in a good way, I think I need to be kept as far away from production physically as possible. I think I need to see that. I think I need to understand it, but it should be read-only for me. I shouldn't be able to damage that thing, because developers kind of, we're tinkerers and we break things, myself very much so. And the fact that DevOps sort of saved us in this sense, being more responsible. My DevOps friends are always the more cool-headed engineers, and in that sense, it's important that even staging is stable and relatively far off from people like me.
No, I agree wholeheartedly. I believe that staging is where you make sure that you've got all the data collection configured properly, so that you don't even manually set that up, because you never know what can go wrong. So I would always want a situation where I even test my observability in staging and apply those settings to production as part of my deployment process. And there should be no need to fiddle by hand on production. You should be able to collect the data that you need. And there's going to be cases where things go badly wrong, and hopefully you've got the data that allows you to reproduce the problem on staging. And then if not, yes, then you've got these tools available to dig around, and you can use things like feature flags to change stuff, or because maybe you've got a thing that says X% of my traffic goes to this new feature, and you can then tune that down so it impacts fewer people, and you can collect the data, or you can turn it up for a while because it's only sticks out its head when you reach a certain load. But I mean, the tools available are incredible compared to just a few years ago.
It's a completely new world in terms of the observability market. There's tools that provide a level of insight, APMs and features of that type that are absolutely amazing.
Oh, definitely.
Speaking about tools, I see that you have a Visual Studio Code plugin, and I know that most of your demos there were IntelliJ. And I just happen to know someone who's very heavily invested in Visual Studio Code.
I mentioned Visual Studio
invested,
Code.
yes. Yeah.
I
No. Do you have a
mentioned Visual
demo of that? So they just install it from the marketplace.
Yeah, you can. I have something better than that. We just announced like last week support for Visual Studio.dev, Visual Studio Code.dev. So it's actually, it works directly on the web. You can literally open a GitHub project in I forget how you do that. And
you just go dots. So you can go, well, GitHub.
You can go that thing.
Dev,
Yeah, and directly into a GitHub project with Visual Studio Code and debug directly from that, and it just works. It's actually a better looking plugin in some regards than because it's newer and it's and web developers worked on it. That's part of the advantage. So they created a better looking UI than I did. I actually wrote the original implementation of the whole thing. I wrote the plugin and the server and a lot of the stuff because I was the first employee at Lightrun, and like half of that stuff is my code. But the Visual Studio
you can be pretty proud, eh? You can be proud of this. It's pretty incredible.
Thank you. It's really cool. And I wrote some of the code of the Visual Studio Code, but I suck at JavaScript, TypeScript actually. I'm terrible at that still. So I didn't write all that much from that. But it came out amazing. It looks really good. And like I said, you can just go there and try it. When I initially created the demo, and I'm still more used to IntelliJ because, Java guy is, I moved to IntelliJ from NetBeans. I'm that, that kind of guy, ex-Sun. So even that, getting me to Visual Studio Code is like another 10 years or so for people like me. But I have it in a different presentation. One of my other presentations, I show Visual Studio Code as well. But you're right, I should demo it more because I think lots of Kubernetes guys use it more. So that's a good note. I'll try that.
Are there any questions? I've seen some people just commenting with mind-blown icons, and I think we've got people might have actually passed out and they're waking up now because they've got this PTSD that goes back maybe 6 months on some project, and now they realize there was a way to solve all those problems, and now it's all new PTSD. Because this is it's incredible because when you look at it's not, I mean, when you see it in action, it's so obvious. Yes, you can do that. You can look at what's going on. You can collect the data, but the tools for doing it yourself is
it's in a way we went backwards because to get the stability we added all the layers in between us and the servers. It used to be that we could go and kick the servers, and that's no longer.
There was something happened that people lost trust in the developer, so they just obscured it away.
We earned that. To be fair, we totally earned that. They improved. There used to be a fail whale, and now it's not as common. And we reached scales that you couldn't have imagined, 10, 15 years ago. So it's pretty incredible. But we also lost some stuff when we got that progress. And now there's sort of the observability movement is sort of trying to bring back those capabilities without giving up the gains that we made in scale and stability, etc. So, and process. you know, so sort of shift left. It's part of this bigger trend of doing things, moving things back to the hands of developers.
Yes, it's actually, I mean, you answered all the questions that I may have, apart from some of what would be going on under the covers. I mean, do you do, I assume you do a lot of code instrumentation.
Yeah.
Is some of it dynamically switched on as you set these things?
So it all, okay. So there are things, the way that it works is obviously every implementation is a bit different. There are some things that are similar. The way all of these implementations work is by having a management server in the middle. So it actually sits either in the cloud or on-premise. Lightrun has both options. Some have only one option. And this server is essentially what the IDE connects to. So, or some people have IDE integration, others have only a web interface, things like that. Everyone has a different approach. We also have a CLI beside IDE support. And it connects to that management server. And that way you don't have the problem that JDWP has, where you need to connect to an actual physical server that's sort of hidden. So the agent, which runs in the pods in the individual servers, connects to the management server, either in the cloud or on-premise, and sends sort of a ping there every once in a while. And if there's no actions, it doesn't do anything other than check every once in a while to see if there's a new action to add to the agent. So that's the whole overhead. When each language is obviously a bit different. In Java, I can talk a bit more. It has you sort of register an interest in something when you load. So we need to register an interest. Now, this raises sometimes a question of, can it run together with an APM and things like that? And usually the answer is yes. It can't run with a debugger because then there is a conflict. But it can run with an APM because we register different interests usually. And the thing is, when you actually place an action, then we go to the line of code and essentially place a breakpoint like you would normally, but we don't stop there. We sort of place and continue to perform all sorts of things. And it can be one breakpoint, can be a bit more complex because obviously lines of code don't necessarily map to bytecode. So there's a lot of awesome code that goes into the whole way the bytecode works, especially with metrics. It's a really there's some complexities there.
Yes.
But the general idea is that we work pretty much like a debugger does, only we do it completely locally. So there aren't any of those faults that I mentioned where obviously no port is open or nothing like that. There's no multiple stages for the debugger to fail in between because of a network issue or something like that, because it's all done in a single operation. And every condition that you send is obviously in a sandbox. So it's conditional breakpoints and things like that are all sandbox verified before that. There's no mutating element. And if there's too much depth that we can't scan, fail. You know, we don't let you do that. You know, it's we're very conservative in that sense because we'd rather that you won't be able to put this feature or log than, you know, production is above all. Never let it come into
don't deploy on a Friday, hey, as much as you want to. Well, wait. So what you're saying is that we can deploy on a Friday.
I deploy only on Fridays. Literally.
I deploy when it's ready. Simple as that. Question I have is so obviously there's some overhead to this process. What is your typical runtime overhead?
So we measured at most 0.5% overhead for no actions. And in the worst case scenario, we measured, when you have multiple actions and things like that, we measured a 7% overhead, which is better than APMs. In most cases, we measured against them. And that's when we actually have multiple actions, not something that's, and a heavy load, obviously. So, but obviously, it's vendor benchmarks, it's hard to tell. Generally, because it doesn't do all that much when it isn't running, it's
then it must be very
not so much a problem. And when it is running and you do put actions, you can tune it, because we have a configuration file, at least in our case, where you can define the level of overhead you deem acceptable. So you can reduce that. The default is actually low. Most people raise the default because they're willing to sacrifice a bit more CPU than we normally give them, to say, okay, I want to see more logs when something, or I want more complex methods to be able to execute them in production and get some more details. So usually it's the other way around, that people want more details.
Because they invariably chose something
too
high up in the
conservative
stack to start
default.
looking at, and then they realize it's deeper down, and
No,
then they
it's
might
less
forget
for
to
the
turn
stack
off.
snapshots. Snapshots are usually okay because it's a one-off. When you get a snapshot, it's a one operation, so it's more expensive, but it's just one shot. The case of logs is actually more complex because it happens again and again and again. And in it, you can put a condition or an expression, usually that includes code. And that code might be expensive. Executing the code in a sandbox is more expensive than executing it directly in the virtual machine. So it's an overhead, but it's worth it, obviously. So in those cases, people sometimes say, okay, I want more CPU for executing the expressions here because I want more logs to get more information. Our default is very conservative, so sometimes people choose to raise it.
Okay. Let's see. Do we have any questions? No, I don't see any more questions. Mr. Motlala, how are you doing? He's joined us on the Slack. Have you got a question? Let's give him a moment because there's a delay from when I speak until it's out on the stream. So the response might take a moment before it reaches us.
I see a question here. Someone asked, not in the channel.
Where did they ask?
Why you used Ubuntu-based image instead of other distros? Well, Ubuntu is common, so it's pretty much something that lots of developers have on their desktops and are used to. So it's very a common thing.
Yeah, I've seen an interesting thing in that. I recently joined VMware as part of the Spring team, and in the one project we create containers using the Paketo bulk packs, which is a standard way of creating containers for many different environments. And I noticed that they stick with Ubuntu instead of using something like Alpine, which will be a lot smaller. And my question was, well, why? I said, well, because we get commercial support for Ubuntu, which means we can offload that work, which means that when something goes wrong, we've got somebody else we can call in instead of needing an Alpine experts on the team to help find a problem, whether it's security related or performance related or whatever. Yes, Rory.
Yeah, so we have our own ISO image that we use at Microsoft that basically also just includes, it's the standard image, but it also includes as Azure Sphere OS. So if you have an IoT requirement, then you can plug the device into IoT. It also is patched heavily. You know, if you've got cloud devices there, nothing is insecure as a cloud OS there. So you want to, as soon as the CV in comes, take advantage of your cloud distro. Yeah, so the only problem with these distros is that they're a little bit bigger than Alpine. They're not really made for performance as much as, you know, conformity. So we are looking at smaller, hyper performant ones with a disclaimer. Listen, if you're going to go that route and roll your own, you need to know that what you're doing.
Well, that's, I think people are prepared to, or they unwittingly accept the risk because of some other constraint, be it the organization's limitations on bandwidth or disk. But if you're not prepared to spend money on those, are you going to spend money on security? And then you're in trouble. So I'd rather have a bigger distro with extra stuff built in to help protect me, and that comes from a supported environment, and something that is a lot smaller, but a potential risk, because you just have to go and read the kind of exploits that are out there, and these people have developed exploits that leverage the weirdest corners of the kernel and stuff, and those exploits usually assume the smallest footprint. They won't go and leverage something that might not be there. So they attack the kernel, and they knock on the door in a specific sequence, and something opens, and it is there's always a risk no matter what you do, and if you've got something that can protect you, it's much better. So I would rather take a bit of an overhead, being it a larger container, it takes a bit bigger.
No, we're gonna get it smaller, but you know, with Java 17 coming out so soon, you know, you have to like rush quickly, J-link everything. You know, now Java, we're planning ahead for Java 30. Like literally, we have a roadmap for Java 30. How do you even slow down when you've got all of that?
Yes, but you start shrinking it once you've you know where you are. Whereas if you start with a small thing and you continuously patching it because of risks, then you just have one big patch job. Whereas if you're deliberate about what you're doing, and you decide, okay, we don't need this thing, we're going to take it away because nothing depends on it, and we found no value. That's a lot better than plugging holes all the time. So it's always trade-offs, and in the case of security, you can't imagine what trade-offs you need to make. So you can never be too careful. So I would always defer to people who are getting paid for the job, and somebody who only focused on making it small, and I don't know what they missed, which is
yeah. So I did a session recently with CodeQL with GitHub Advanced Security, and I did it with a colleague of mine who hacked me in real time. And I was a bit taken back because I didn't know even those exploits that you could use. And for any seasoned hacker, you're just open. You're just completely open. And it's not only that, but the degree of security. So now it's great to have your scans go deep into your container, but you don't realize what small tokens you leave in your code or your properties or your settings or whatever. Now, all of the newest craze is to go deep into your projects and to see, has the person put in any secret stores or anything linking to any personal information? Never mind the secret. It's like your dog's name. If you accidentally put Rover inside your code base, they're going to tell you, listen, Rover's not supposed to be there. And that seems to be a big industry trend, to go in and try and like pull out all your secrets that could possibly, link through to your passwords. To me, passwords must die. They must die. We must have two-factor authentication, and you must have a device space with own biometrics. This is not going to work out. I don't even know what my network password is, because it's become so what's the right word? Normal for me to use two-factor authentication.
Exactly. I've got a ritual in the morning. I have to use my phone to unlock various things before I can work, and then I'm up and running. But
do not shower.
You can
do not
torture
shower
me.
or bath before you do that. Okay. So I learned it the hard way, and then you get a wrinkly finger, and then the thing doesn't even pick you up, and no eyesight and everything like that. So like I literally become unrecognizable in the morning. I drink my coffee, and then I do the biometric stuff when it actually picks me up.
Yeah, I mean, you can torture me and I won't be able to tell you what my passwords are, because I don't know what they are.
Neither.
It's as simple as that. I know one long password, and
it's probably expired. You go in there and you try.
No, but it's one that nobody will guess. It's just a long sentence that only I know. I never share it, and that unlocks my my password management tool. And but it also needs my biometrics, and that's how it should be. It should be something you know, something you have, and from there on, because people think biometrics is a password, whereas biometrics is a username.
So I work on this same principle with chocolates for my children, because they just steal chocolates and then they run around, murdering each other. So I lock the chocolates in my office, and then I take the key and I put it into another room in a locked area there, though. And then they have to know me. They have to know where the key is. And they also have to go through the effort of actually doing that if they wanted to steal the chocolate. And that's never going to happen.
I'll remember that you are pretty stingy with your chocolates.
No. Microsoft has a thing that at the end of the month that people go in there and they get free food and everything. I bought chocolates for them. So I literally bought 2 Pick and Pay bags worth of chocolates. And then I made the mistake of actually showing it to them, and they go, okay, that's ours. And I go, oh, damn it, what did I do? Okay, I think that Shai needs to run, because now he's worried about us and chocolates and everything. Shai, thank you so much. It's great to see you again.
Thank you, guys.
Thank you for your time. And I hope we can meet in person one day. Maybe we can lure you down to come and visit us.
By the way, I'm organizing a conference in Tel Aviv on January 31st. I hope to see you all there. Microsoft's invited, obviously. As are you, Rory. I hope you'll come. It's going to be fun.
Great.
So, Tel Aviv.
Thank you so much for your time. It was wonderful. And thank you, everybody, for joining us online. I'm going to share the link for the feedback form in our Slack channel. And if you want to be entered into the competition, the draw for the JetBrains license, then complete the feedback form. Thank you very much. And everybody stay safe and stay healthy. And we see you next time.
Cheers, Shai. Cheers, everyone. Bye.
Bye-bye.